In the case of this another example, bicycle class, it is going to contain the attributes like frame size, wheel size, number of gears, materials used for that. What are the operations that we can expect from this? So shifting of the gears, moving, then repeats. These things can act on the attributes. What is polymorphism? Polymorphism is one function, a number of operations that it is going to be. Name is going to be one, and you can pass the parameters to such a way that so it is going to draw that particular operations. Here is the example. Same operation, but different classes. Okay. Circle is a class that it is being said to draw it, so circle is being drawn. Draw is a one function. So it is saying that ability of different objects to respond for the same message in different ways. Draw is a function. So you can draw anything that it is. Circle you can draw, rectangle you can draw, triangle you can draw, rhombus you can draw. Draw is a function, and input that anything that you are going to give it to that related to the draw functions, that it is going to draw the objects. Inheritance. Inheritance in a simple manner, you take the inherited family, they will be going to call, and the father's natures. Okay, example if it is. So father's nature is going to be present in the child. Okay, those things are going to be inherited. There is nothing but some of the features of the parents is going to get inherited to the children's. Similarly, any object, any classes will be there. Those class functionalities are going to be inherited to the child classes. Okay, that is nothing but inheritance. Here it has been given one of the example that saying bank account is there, then checking the account and savings account. Okay, so when it is bank account is there, there's a owner and balance is there. Next, the functionalities that is going to work on that is deposit and withdrawal. Now you see the savings account. Now here percentage is there. There is annual the rate of interest is the percentage that it is going to be. Deposit monthly interest. Okay, so this is a function. So there's a deposit is already there, that it has been inherited over here. Withdrawal is there, that withdrawal function is there, so that it is being inherited in the savings account. Okay, now here also in the checking account, withdrawal is been there, that is amount in dollars, and the same amount in dollars is here also, that is in withdrawal checking account as well as savings account. So what happens basically is the functionality is only once time with contract, and you can inherit the in the other child classes. So you need not write the same functionality repeatedly. That is the advantage of inheritance. Object-oriented development. Here there is a cycle is there. So as we are going to proceed with the first chapter, there is a waterfall model. So how that flow is there. Similarly, that here also you are going to have the life cycle of the software life cycle is going to be present in this. Object-oriented development contains what? Object-oriented analysis, object-oriented design, and object-oriented programming. All three together is called as object-oriented development. Means if you want to use in this scenario, the programming is also going to be different, then design is different, and analysis on that is also going to be different. All three together that you will be going to, it is going to be called as object-oriented development. The life cycle of this is similar to that previous one, that is the waterfall model. So feasibility study is going to be done in this, requirements analysis and specification, design, coding, testing, and maintenance. Now you see everywhere 5 points we will be discussing in continuously. So that is requirements analysis is there, and the specification, there is nothing but SRS it is. Then designing. Okay, this here in the design is object-oriented concept design it is going to be. coding is related to the programming. Okay? Object-oriented programming it is going to be. Then testing is going to be there. So you have to test the classes, models, the functionalities of those things that you are going to test in this. Finally, the maintenance is going to be present. Feasibility study why you are going to do is because whether your project is going to accept or so can we use this project for the development for the OAD concepts that we can able to adapt in this. For that the feasibility study is required. The methodology that you are going to use for the object-oriented concept. So graphical notations that you are going to use it. So OML, that is class diagrams, okay, and then generality diagrams and all these things that you are going to use it for the application development for the object-oriented methods. So here the two stages are there. There is a system concept and analysis. In the case of system concept, the development is going to be based on the business analysis, okay? And some temporary requirements are going to be taken and it is getting executed. Then analysis based on the requirement, understanding of the problem statement. These things are going to get implemented by using the class diagrams. Okay, so here you are going to use class diagram more and more because whenever that business is present or business analysis is going to be present in this, then what happens is basically the inheritance concept and polymorphism concepts as well as the encapsulation. So these three things are going to be present in the object-oriented methods. So all three things that you will be going to use because the safety is important for the functionalities are going to be very, very important in this. Because of that, you will be going to use this class modules for the development of this particular programs. The main thing in this is reusability. That is the major advantage over here. Now you have seen in the polymorphism only one function you are writing. Which function it is? Draw function you are writing. So for the draw function, any input that you are going to give it related to draw, that it is going to draw. It does the output. For example, input it has been given with 3 inputs. Okay, triangle is going to be drawn. Okay, 4 inputs if you give. Circle is square is going to be drawn. Okay, based on the inputs that it is going to be, it's going to draw. The drawing process is going to be get executed. That is a major advantage for object-oriented methodology. The analysis contains 2 parts. Again, domain model and application model. Domain model is going to have the real-world objects. So you must know what are the things that it is going to present and how that is going to get executed. Domain knowledge is domain objects for the stockbroker. It's one of the application area it is where the stockbroker information you must know everything in that. Then only you can able to do the programming. Application model. There are so many applications with there. Stock, bond, trade, commissions. All this is the functionalities of the application model it is going to be. So it is going to be visible to the user. It is going to be visible to the user. The implementation task is going to have the classes and the programming languages will be there in that. Databases are there. Hardware design is also going to be there. All these things come together used for the implementation of the project. The important thing that you should follow in the implementation is that engineering concept traceability is very, very important thing, where and all the mistakes are going to happen and how the data is getting flowed in between the systems, classes, that it should be known. System design. So we are going according to the design cycle it is going to be. Okay. System design. You will be going to have high level design and low level design. High level design, the abstract notations are going to be present, and in the low level design, the programming concept like your class diagrams are going to come into the picture in that. Then class diagrams, class design you can say, it adds to the